Hello viewers, welcome to the section Integrating Machine Learning with Computer Vision. In this section we will learn about Introduction to Machine Learning, Logistic Regression, Support Vector Machines, K-means clustering. Now we move on to the video Introduction to Machine Learning. In this video we will look at the importance of machine learning. Also we will discuss about the examples of machine learning in computer vision. The concept is fairly simple to understand, but certain sophisticated algorithms require rigorous understanding of mathematics to make sense of what they are doing. The task of learning shapes is an example of supervised machine learning, where we give the data and its corresponding label as input to the system to learn. Another vertical of machine learning is unsupervised machine learning, where we only provide the data without any labels to the system, and it implicitly tries to group data that it feels belong to the same label or category. An important aspect of machine learning is the training data, the data through which we make the system learn. The quality and quantity of the data both matter equally. If there is not enough data, you will never be able to make the system robust. If you do not have quality data, you may not be able to infer new, unknown data. There are a lot of openly available datasets for various tasks. Some of the famous ones are CAFAR and ImageNet for image classification. Image translation means that the XY position of the image changes in the input image. For example, we train our program with images of a pen at the center of the image, and while testing, we give an image with the pen at one of the corners of the image. It is possible that the program might not detect the object as a pen. To tackle this problem, we try to move the object to different positions in the image by randomly cropping the image at different positions. Image rotation and scaling is similar to image translation, only this time we rotate a given image with random angles. This helps the program to learn the object at different orientations. We also scale the image and make it smaller or bigger before we pass it to our machine learning program. These simple techniques are a way of artificially expanding the original datasets and go a long way in making the program more robust and invariant. There are other pre-processing techniques, such as color averaging, that could be used too. Before diving into machine learning algorithms, let's install a new library that is scikit-learn. Like scikit-image, scikit-learn is another open source library that provides easy-to-use APIs for most of the machine learning algorithms. Installing sklearn is fairly simple. Now we will see some steps which show how to install it on various platforms. Assuming you have pip installed already, run the pip3 install command in your terminal window. To verify you have successfully installed sklearn, run the Python 3 c import sklearn command in your terminal. If you see no errors, you are good to go. Machine learning is used in situations when we want the computer to operate, infer situations, or make decisions without any human intervention. Just like a human being, to make a computer capable of these features, we need to make the computer learn these situations in advance before the computer can understand these situations independently. An example of this could be to recognize faces in an image. We need to tell the computer in advance what is a face, what it looks like, and what are some specific features that can help us detect a face in an image. You can now see examples: handwriting recognition, image detection and classification, scene labeling, self-driving cars. Now we will discuss each one of these examples in detail. First, we will look into handwriting recognition. Handwriting recognition is one of the most common applications of machine learning in computer vision. This finds use in number plate detection, building applications that can translate signboards written in a language you do not know, and more. Then we move on to image detection and classification. Image detection and classification is to identify where in the image is an object and what is the object that is being shown in the image. Is it a mobile phone, a car, or a pen? Many online retail e-commerce websites now have a feature where you click on an image of an object and it looks for it on their platform. This is nothing but image classification. Next we will discuss about scene labeling. Scene labeling is an interesting application of machine learning in the context of computer vision, where given an image the computer tries to label it. Finally, we will learn about self-driving cars. Using machine learning and computer vision, researchers and technology companies are building autonomous cars that can navigate their way through traffic and obey traffic rules. These cars are fitted with cameras that continuously monitor their surroundings and detect people, cars, and other objects on roads. In this video, we have introduced machine learning.